The other main use of topographic maps is to determine the location of things that are on the map. Now there are two ways of doing that. We use systems of coordinates, and the first one that most people know of is latitude and longitude. Okay, I thought I'd just jump in here and give a quick lecture on this section of topographic maps. Thought it might be easier than doing it at the bench, so to speak. So we're up to finding out how we locate things on a map, and we use two systems. The first is latitude and longitude, which you've probably heard of, and the second is eastings and northings, which may be new to you. So we're going to look at latitude and longitude. Latitude and longitude is a grid system that is placed over the entire globe. You can think of it as an X and Y grid system in two-dimensional space, with X being the equator and Y being the prime meridian that runs through Greenwich outside of London, where we get Greenwich Mean Time. And so latitude and longitude are the two grid points by which you can locate any point on Earth. Now, we could divide up the Earth into four sections, into quadrants, and designate each of those, whether they're north of the equator or south of the equator or east of the prime meridian or west of the prime meridian. And you end up with this sort of system. So anywhere, all points in North America would be north of the equator and west of the prime meridian, and Australia would be, of course, south and east. Okay, so what is latitude? Well, latitude is the distance from the equator along the y-axis, going from 0 at the equator up to 90 degrees, which is the top of the globe, at the North Pole, and 90 degrees south, which is the other end of the globe. So it's like a right angle. So it's just divided up that distance from the equator to the poles into 90 degrees. So it is a measurement of distance, but we use it in terms of degrees. So the unit of measurement is actually degrees. And the reason we use degrees is because when this system was devised hundreds of years ago, as people started to sail around the globe, they didn't have accurate techniques of measuring distance, but they did know about degrees in a circle. They knew the Earth was circular, and so they just divided up the Earth into these degrees. And it worked quite well. We're still using it. With latitude, each degree of latitude is divided into 60 minutes to give you a more accurate, give you the ability to place yourself more accurately on the Earth's surface, because 1 degree covers a very large, very long distance, and so you divide that into 60 minutes, and then more accurately you can divide your minutes into 60 seconds. And the same is also true of degrees of longitude. So for example, we would express latitude as something like this accurately: 36 degrees, 6 minutes, 9 seconds south. And you can see the marks that we use for degrees, which is a little circle, which you probably knew, a dash for minutes and 2 dashes for seconds. Okay, so what is longitude? Well, longitude is the distance from the prime meridian along the x-axis, again measured in degrees. But because we've now got the full circle going all the way around, we measure from 0 to 180 degrees east and 0 to 180 degrees west, covering the full 360 degrees of the Earth. Okay, so what is my location? Well, I'm just outside Albury, and so my location in latitude and longitude is 36 degrees, 2 minutes, 27.2 seconds south, 36 degrees, 2 minutes, 27.2 seconds south, and 146 degrees, 59 minutes, 26.1 seconds east. You always have to say south and east. You always put latitude first and then longitude. You can also represent it as a decimal, so you can convert your degrees, minutes and seconds to a decimal degree. You don't want to do it in your head. There are plenty of online ways of doing it. It's just a simpler, more modern way of doing it, but really the old system works fine and has for hundreds of years. So you can represent, and you may often see it represented as a decimal degree, useful if you're putting it into spreadsheets or in computer programs. and that would be that same longitude represented as a decimal. You can see there 146.99. See how that's close to 147? Well, you can see that in the old, using the minutes and seconds, 146 degrees 59 minutes, 26.1 seconds. So that's almost 147 degrees. So you can see how that relates to the decimal degree. All right. So what does that look like on a map? Now you'll see it when we get back to the bench, but I thought I'd do this because it's a little clearer. This is what you'll see in your on a map, and you have lots and lots of numbers. Now these are the numbers that you use to determine both latitude and longitude, and also the eastings and northings, which we'll look at a bit later. Now I'm just going to get rid of all of the numbers we don't need for latitude and longitude. So we black out all the ones that we don't need, and we just leave ourselves with 140, in the top left hand corner. Our latitude is 36 degrees 45 minutes 00 seconds. Come down, you'll see that black line comes down to 46 minutes. So this would be, so halfway down is 36 degrees 46 minutes 0 seconds, and that would just extend down to the bottom of the map. And then our longitude there is represented by the number on its side, 147 degrees 15 minutes 0 seconds, and coming along again at the end of this black line is 147 degrees 16 minutes 0 seconds. Each topographic map is divided up into minutes, and with alternating black and white sections indicating the length of the minutes on the topographic map. So how do we find this point here? Well, let's do our latitude first. Let's bring in a line of latitude, and thankfully it falls pretty close to 36 degrees 46 minutes south. Now just ignore those faint straight lines on the map itself, those squares there, because that's eastings and northings. All right, so you have to ignore those. That's our latitude. What's our longitude? Well, let's bring in a line of longitude because it measures things east and west. And oh, what do you know, it falls exactly on 147 degrees 16 minutes 0 seconds east. So our latitude and longitude is just represented that way. Okay, that one in the middle there, you have to now interpolate between the data that's present, or the numbers that are presented on the map. So what would that be? Well, it's halfway between 45 minutes and 46 minutes. So it would be 36 degrees, 45 minutes, 30 seconds. And the line of longitude is similarly halfway between 15 and 16 minutes. And so you designate that with 30 seconds. Okay, let's stop there and get back to the bench, and we'll just jump right back in. So let's concentrate on the bottom right hand corner of the 1 to 25,000 map. So down the bottom here, you can see this number here, 36 degrees, 7 minutes, 30 seconds. Okay, so that's a line of latitude, so that's south. 36 degrees, 7 minutes, 30 seconds south. That's away from the equator. The number that's nearest it, 147.0000, is a line of longitude, and that's 147 degrees east. Okay, so the latitude and longitude puts a grid over any map. Now, where that grid occurs, it's not written as a grid on the map itself. That's the other system, which we'll look at in a minute. You have to interpolate, but where does the latitude and longitude change? How do you determine that? Well, along the edge of the map, you'll see these black and white lines going along the bottom of the map, and again black and white lines going up the edge of the map, up there. Each black or white line is 1 minute of a degree. Okay? So here we have 147.0 minutes. Now there's a black line there. Well, hang on, what does that mean? Well, there's no number there. But here we are, over here, we have a number that looks like a minute. It's got that little dash on it at 58. So this is 147.00 Now because we're heading west, that means we're going down in numbers. So this, like, we're going backwards. So this would be 146 degrees 59 minutes, 146 degrees 58, 146 degrees 57, 146 degrees 56 that you can see there, 55, 54, 53, and this line here is half a minute, so that's 30 seconds. So we end up with 146 degrees 52 minutes 30 seconds all the way over here. Going up the map, starting over here, we have 36 degrees 7 minutes 30 seconds, so we're already starting halfway through a minute. You can see that the length of that line is half the length of that line. And so because we're now going north, again, we go backwards, back to 0, which is the equator. So 36 degrees 7 minutes 30 seconds. There's that black line there. Let's go up to the next white to black, and we've got an 06 there, and so you've got to try and ignore those numbers. Okay, so here we have 06, and perhaps I'll black that number out for you. So here we have 06, so that's 36 degrees. That would be 7 minutes 0 seconds, and here we have 36 degrees 6 minutes, 36 degrees 5 minutes, 36 degrees 4 minutes, and so on up the map. And so once you know that, if you say you have you wanted to, let's say, find the location of this particular point, on Ryan's Creek, then you would just draw a line down to the bottom, at the x-axis, down at the bottom of the map, and find out its longitude. So 147.00, that would be 146.59, 146.58. It's about halfway between 146.57 and 146.58. So the longitude then of that point up there would be 146 degrees 57 minutes 30 seconds. And then if we go over onto the y-axis to get our latitude, we've fallen pretty much just north of what would be 36 degrees 6 minutes. So we'll say that's 36 degrees 5 minutes 58 seconds. All right, so just north of 36 degrees 6 minutes would be 36 degrees 5 minutes 58 seconds. And so you write those two down. I've forgotten what they were. That's your latitude and longitude. And you can use that anywhere you like on the Earth's surface. Now, that is in fact not the way we usually report location using topographic maps. There is a slightly easier and more accurate way of doing it. Over every topographic map, there is a grid system put on top. Now, if you look closely, you'll see that they are helpfully drawn on the map itself. Okay? You can see them there, and they go across the entire map. Again, the numbers that relate to those grids are printed on the bottom of the map. Now this time you have to ignore the numbers that relate to the latitude and longitude. Got to sort of put them out of your mind. And just look at these large numbers here. So let's start in the bottom right hand corner again. So here we have a line here, and it's 99, next one's 98, 97, 96, 95, 94, 93, 92. These are called your eastings. Okay, so we'll now do a quick presentation on what eastings and northings are. Okay, and so the second way of finding your location, or the location of anything, is using these grid coordinates. And we can use these to more accurately locate positions on a map. Now each of the grid squares, if you look at a topographic map, and we saw examples of them in the last lecture when we were looking at latitude and longitude, each grid square is 1 kilometre by 1 kilometre. Now, not always, there are some very small scale maps where the grids are different, but most of the maps that we use, the grid squares are 1 kilometre by 1 kilometre, which is useful if you need to quickly determine the distance between things. You can use these grid squares. And it's these that we define as eastings and northings. Okay, so eastings are the vertical lines numbered left to right because they're measuring distance east, or west, but east. Okay, so they're measuring distance east, so that's why we call them eastings. They're the lines that are vertical because they're measuring distance to the east. Northings are the horizontal lines numbered from bottom to top, and we call them northings because they're measuring distance along that northern direction. We always read eastings first and then northings. So when you describe the grid coordinates, it's eastings first, northings second, which is opposite to latitude and longitude. But anyway, so it's eastings then northings. Okay, let's look at a map. Here's the same map. Like we did before, we got rid of all the extraneous numbers. So let's do that. In this case, we're going to get rid of all the numbers that are related to latitude and longitude. Okay, there they go. Plus the other numbers that are around the grid coordinates that we don't need to worry about, like that 59 that just disappeared there, and that 59 there that's about to go, hopefully. There it goes. Okay, so they're the numbers, there are eastings and northings, and you can see there the faint grids and the numbers next to them that are the eastings and northings. So the eastings are along the top, 23, 24, 25, and the northings are down the side, 30, 31, and 32. Okay, let's put the other numbers back on just to confuse us. Let's find an easting. Now this is actually what the map really looks like. All right, there's the actual numbers on the map, so we'll leave them all there. What's the easting and northing, or the grid coordinates for that particular point? Well, what's the easting? Let's get it over there. It's halfway between 24 and 25, so it's 6. So its 3-figure easting is 245, and the northing, bang it on, is halfway between 32 and the next one, which would be 33, and so that's 32.5. So our grid reference for that point, we describe it as 245, 325. You can also give a 4-figure area reference. If you need to describe a whole area, then you just give the 4-figure area reference of the bottom left-hand corner of that grid square. So in this case, it would be the area reference would be 1201. Eastings first, then northing. Okay, 1201, and that represents that whole square, and that represents 1 kilometre squared. Okay. All right. And now that we've come back, we can now work out the location of something using our eastings and our northings. So whereas we always have latitude first and longitude second, when we report using the grid, we always report our eastings first and then our northings. I don't know why, it's just convention. So it's flipped around. So our eastings are the numbers that measure east and west, and our northings are the numbers that measure north and south. So if we wanted to measure that same, or give the location of that same point on Ryan Creek, we would again use a ruler, if you like, and come down to our easting. And so our easting here is about halfway between 9.7 and 9.6, and so the easting there would be 965. Okay, if it was a little bit further, it might be 966. So you divide each of the degrees and eastings and northings. The grid, divide each of the grids into 10 and report the closest you've got there. So 965, and on our northing, it's between 06 and 05, and it's about 9/10 of the way towards 05. So that would be 051, okay, because 05 and 06, we've got to watch which way the numbers are going. So it's 965, 051, okay, would be that point there. You can also report whole areas. They're called area references, which we looked at. And so if you're interested in this whole area of the floodplain, then you report, as I said, you report the bottom left-hand corner of the square in a 4-figure number. So this one, just the bottom grid coordinates, the eastings first, would be 9605. That tells, if you wanted to say to somebody there's a bushfire or there's a flood in that whole square, or well, we think the person's lost somewhere in this grid, then that's how you would report that. And then somebody with the same map could go to that point and start doing whatever they had to do. All right, so that's our coordinate system and how we locate ourselves.